Hello and welcome to Quartic Training. Quantitative methods, study sessions 2 and 3. We have got 8 chapters here. This quantitative methods is one of the bigger subjects. It's 12% of the curriculum, which means around 28 questions. Each subject is split roughly evenly between morning and afternoon paper. So if there are 28 questions, you'll get approximately 14 in the morning and 14 in the afternoon. It's also, when we do the exam, you'll see it is in roughly study session sequence. And although we don't teach entirely in study session sequence, you'll see these are study sessions 2 and 3. And this means that after ethics, which is study session 1, this is your second section of questions in your actual exam. We start off with time value of money, which is the idea that we prefer money today than in the future. We will be setting up the calculator, we'll be drawing lots of timeline diagrams, and we'll be learning how to do a lot of questions that can take many shapes and forms. Chapter 6 is discounted cash flow applications. This is a slightly miscellaneous chapter. We look at 3 different topics here. First of all, net present value and internal rates of return, which is kind of more corporate finance. The second part is manager appraisal. We look at holding period return, money and time weighted rates of return, which is more portfolio management. And then thirdly, we look at money market yields, which is almost fixed income. So we have 3 different sections taken from 3 different topics, but all put into quants for today. Statistical concepts and market returns, lots of definitions of how we deal with stats and probability so that we gain a full breadth of language so that we can describe things. A lot of that may be familiar to many of you who've done a bit of maths at school or university, but we'll go through a lot of calculations as well, measures of central tendency and measures of dispersion. Probability concepts, looking at how we define probability, how likely things are to happen. Quite a few definitions, quite a few calculations in that, and that leads us into reading 9, the first part of the application study session, which covers a number of distributions, in particular discrete distributions such as the binomial and continuous distributions such as the normal distribution. 10. Sampling and estimation. If we want to measure something about a population, then often the population is going to be very big. We want to measure how long it takes to wait for a bus. We want to measure how high CFA candidates are. We want to measure how many percentage points a portfolio manager performs. Often the population is so big we have to take a sample in order to measure those items because we're never going to be able to measure the whole population. And it's the theory of that. How does the sample lead us to estimates about the population? Hypothesis testing, often seen as one of the tougher topics, but the way we try and describe it and when we tell you how this is likely to be examined, hypothesis testing shouldn't be so challenging once we've understood the previous chapters. The idea is we make a statement and we try and test for whether it's sensible or not. Statement could be the average height of candidates is 168 centimeters. People score at least 70% in the exam. A portfolio manager is achieving 5% per year. Statements like that, and we test it to see whether they are feasible or not. Finally, technical analysis. This topic looks at charting techniques and tools relating to securities trading. We will look at a number of techniques on that. We will show you, although it's a very detailed, complex topic, we will go into the level of detail that you need, which hopefully is not that great, and that's technical analysis. Let us begin with reading 5, time value of money. This reading is one of the most important foundations for your entire career. What we are looking at here is a topic that describes how we can value future cash flows today. From the content of this chapter, you will be able to value shares, bonds, derivatives, to be honest, any product in the world where we have the ability to estimate cash flows and timing. And you'll find that the skills that you gain on this, you'll be using probably every single day of your entire career. The starting point is we have a rate of return, and the rate of return is the difference between money today and money in the future. Let's say, for argument's sake, we have a 5% rate of return. That means if we put $100 into the bank now, we may expect to receive $105 back in a year's time. Now, what is that 5%? The way I described it, it's an interest rate. But It has a lot of other meanings, and although we're going to look at it in a bit of detail now, you'll see discussions relating to the rates of return come up in almost every topic. We look in detail at rates of return when, in particular, in corporate finance and portfolio management and fixed income, where we look at yields. You'll even find it cropping up in ethics, not so much at level 1, but you'll see the discussion on what rate of return you require is absolutely pervasive in this curriculum. It's essential because it's our benchmark as to whether we are investing in products that are likely to achieve what we require. The first definition is a required rate of return. We must achieve a certain amount. It's because if we don't achieve that return, we could have invested somewhere else. If we need 5%, it may be because there's another opportunity at 5%, and so the project we're analysing, if that doesn't achieve at least 5, we're not going to bother investing here. Opportunity cost. What could we have done with our money elsewhere? Similar to that previous example in a way. If you could achieve something, if you could achieve a certain percentage, then that's effectively your hurdle rate. If you cannot get over that hurdle rate, then you're not going to be investing here. And the discount rate is the mathematical connection between what we get in the future and what it's worth to us today. In the same way as $100 today may grow to $105 in a year's time, more important is the reverse of that, which is if you've got a $105 cash flow in a year's time, to us that's worth $100 today. We can break this down into a number of components. The first split, the first component, the first way of dividing it is into risk-free and risk premiums. The risk-free rate is a notional rate of return that we can achieve without any possible risk of losing our income or our principal. Traditionally, we would normally talk about US government bonds or US Treasury bills. Of course, in these more controversial times, that's slightly harder to do. From our point of view, we need to think of it as this theoretical rate that gives us a probably very modest return for absolutely zero risk to our income and capital. This can itself be broken down into real and inflation. When we talk about a real rate of return, the real rate of return is what is our spending power going up by with a risk-free return. If we have got high inflation, that will reduce the amount of return we've got. Very simple example, let's say we've got $100 and let's say we have an interest rate. This is called the nominal risk-free rate. So let's say risk-free rate is 5%. That is a nominal risk-free. And when we say nominal, that means that is what the bank is paying us. You put $100 into the bank today at 5%, then you're going to get out $105 in a year's time. So we start off with $100 and we know that's going to grow. And when we multiply up, although we may describe it as adding 5%, what we really mean is multiply by 1.05, and that gives us $105. That's the nominal rate. Let's say we have some inflation. Let's say we have inflation of 3%. Now, intuitively, you may say, well, look, we've got 5% rate of return, 3% inflation. That means we can only spend 2% more. It's not exactly 2%. Let me explain why. Now, if you say it's 2% in the exam, the chances are that'll be absolutely fine. Because in the exam, they don't give three answers that are so close together that a rounding error can get you the wrong answer. However, we may as well do this accurately because we're going to be doing this calculation a lot. If inflation's 3%, that means it's not going to be exactly 2% real. Let's see what I mean. Let's say when all else fails, what you'll find we often talk in terms of bananas. Bananas are very useful items of fruit because they let us visualize something tangible. Let's say we are looking at bananas that cost $1. In other words, at the beginning, $100 divide $1 means we have 100 bananas. We can afford 100 bananas at the beginning of the year. Now, bananas go up in price over the year by 3%. In other words, if you take $105 divided by 1.03, that gives us 101.94.